So this is like real life data, okay? This is what happens where in the real world, right, we don't always get a nice line that kind of shows how things grow or change and stuff like that. Sometimes, right, it's just kind of zigzags and stuff like that, okay? That being said, though, if you look at it, does it like roughly look like a line? Like, does it roughly look like a line? Right? I mean, could we draw a line through it that kind of like fits it? We could, right? We could draw a line that kind of like, and again, we're not going to connect all the dots. The point is to draw like a line that kind of like summarizes these points, okay? I mean, what's the general trend of the data here? As the years increase, what's going on? The CD sales are going down, right? As the years go on, the CD sales are decreasing here. Okay. So, yeah.
Be very interesting if they had all the way up to the year.
Current years and stuff. I agree.
Then, like, I want to see how much it decreased.
Mm-hmm.
Because now it probably is like nothing.
Very close to it, I would say. Yeah. And then of course you could also look at the data for like records. Because I feel like records have like grown in popularity. People like buy records now and listen to those.
I went to the a Walmart recently, and I remember back in the day they had all these CDs and
right.
DVDs. Now there's like none.
Yeah.
They just sell video games.
Everyone wants the electronics. They just get it like digitally or whatever. But you can see right, and that's part of that trend right here. Okay. Do you guys know what does this mean right here? It's jumped, right. You'll notice here that this is 0, and then it jumps up to 650, and then it counts by 50s. So keep an eye out for something like this. Technically, I think there should probably be one here as well, because we jumped from year 0 up to the year 99 and stuff like that. But
back to the year 0.
What's that?
Back to the year 0 after that.
Oh, that's true. That is kind of weird. I guess they did. Yeah, that's kind of a strange x-axis they gave us there, but oh well. More importantly, right? So. If you were to guess here, right, we want to try and guess about how many CDs were sold in 2006. So what we're going to do, and maybe I need to, I should have passed out rulers, I guess. Okay, what we're going to do here is try and estimate our line of best fit. Okay, we're going to estimate. Pass it down, please. Take one of these, pass it down, please. Folks, if you're watching Netflix or anything like that while we're doing this, it's probably a bad idea, okay? Especially if you're not, getting the homework and you're not understanding stuff, watching TV shows is not going to be helpful, okay? If you have an A in the class, I might be okay with that. But if you don't have A's, that means you still have room to grow. 77? Not an appropriate time to be watching Netflix. Okay? All right. Does anyone own a ruler that they don't need the ruler that I just gave them? Do you have a ruler? No. You need a ruler though. I have a ruler too. Who has a ruler? You do. Do you mind if we let? Here, I'll let. Okay, so back to what we're talking about here. Let's take our rulers here, okay, and try and estimate about the middle of the data. Now, some rules to help us kind of figure out if we have a good line of best fit. All right, you want it to be so that you have the same number of points above your line as you do below your line. That's a good thing to do. If you end up going through some of your data points, that's good too, but it doesn't have to be that way. So let's see here. I see a total of 1, 2, 3, 4, 5, 6, 7. So I'm going to try and get at least 3 above and 4 below, or maybe even go through a point or something like that. Well, either way, it's kind of like you have to split it. So I'm going to do something like this. And again, your line of best fit might be a little bit different than my line of best fit. But something like this, we'll say. Okay? So something like that. You'll see I have 1, 2, 3 below, 1, 2, 3 above, and then I kind of go through one of the points right there. Okay? You do these in science? Yeah.
Remember we did the like the Earth, like the space thing?
No.
You guys not remember that?
Well, so
Yeah, we don't.
So you might have, Sean, and we're going to do our own scatter plots, I think, tomorrow some too. So you'll see that as well. Okay? So if we were to estimate, listen up. So if the trend continued, about how many CDs were sold in 2006? So looking at our trend line here, okay, where would be 2006 on the x-axis? The farthest right over here. Okay? And so about how many CDs do you think that's going to be?
675.
Yeah, I'd say about 675, sure. It's about halfway between 650 and 700, so about 675. What are the units here?
CDs.
Not just CDs. Million CDs.
That's still a lot.
That's a lot still. Yeah, of course it is. Yes, that is still a lot.
I mean, he's not wrong. I mean, he said it.
No, you don't. You have to take your shoes off, and even then, you wouldn't have enough. Okay? So, let's keep going here.
How many seconds? I mean, how many minutes? Is it 1, 6, 675
What are you talking about? Oh, how many minutes of music is that, you mean?
No, yes.
Multiply it by 3.
Okay.
Yeah. CD holds about an hour's worth of music, so you can multiply by 60, and that'll give you how many minutes are in that total music. That's a lot of minutes. But of course, Tyler, some of those are going to be repeat CDs too. All right, let's see. Look at number 2. Number 2, okay, we're given a table. It shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. Okay? So what that means is how much a child costs each year that it's alive. So for example, a 3-year-old child, it's predicted that that child will be cost the parents about $10,700. But if you have a 6-year-old child, that child will now be $11,700, and so on and so forth. You can see the trend here. Okay? So let's plot this data. Okay? So 3 and then 10,700. Well, there's 10, there's 11. For 10,700, where should we be? Probably closer to the 11, right? So maybe right there. Okay, question, Sky? Yes, go ahead. Okay. All right, let's go. Keep graphing there, guys. So 6, then 11,700. So 6 and then 11,700, something like that. And then 9 is 12,600. So that's just a little bit more than halfway. Okay. 12 is exactly 15,000. That's going to be an easy one to graph. Okay, and then finally 15, and it's 16,700. So 16,700, something up here. Okay. Gentlemen. Ella, question?
Yeah, with the annual cost, are they adding say from 3 to 6? Are they adding 1,000, or is that
That's just the cost for that child for that year.
So from January to December, that's how much?
Yeah.
Okay.
Total. Yep. That you'll spend on that child, and that includes, I think, everything from doctor's visits to food to probably like even they might even consider like shelter. You know what I'm talking about, like to house them in your home and stuff like that. So yeah. And actually, the USDA has information about this kind of stuff. It's kind of depressing when I'm like considering starting a family and they like say what the numbers are, but I don't believe their numbers. But anyway, I don't, but that's me. So anyway, though, we're supposed to draw the scatter plot. We did that, and then describe the relationship that exists within the data here. So what kind of relationship do we see? What's happening with our data? How might we describe it? What's increasing? The cost increases as what else increases? Age increases, right? So that's exactly right. So the like single kind of phrase we could say here is we could say positive correlation. Okay, so it's pretty clear here that there is a positive correlation. That means as one increases, the other increases, or as one decreases, the other decreases, right? The thing we have to keep in mind here, and that you have to be very careful of as, human beings and people that are, citizens of this country and, just exist in this world and stuff like that, there is a tendency for us to want to associate the x-axis and say it is independent and the y-axis is dependent. So in other words, there's a tendency for us to say, oh, the annual cost depends on the age of the child. And that's not necessarily so. I mean, in this case, it probably makes sense that would be the case. But in other situations where you're comparing data down here with data down here, or data on this side, okay, when you're comparing two sets of data like this in a scatter plot and looking for a relationship, it's not always so obvious about what relates to what depends on what, okay? And we got to be careful with that, that's all. And if you want to learn more about that, I think they talk about that in statistics and maybe even in psychology too, okay? Where if you see a correlation, that does not mean causation, okay? Doesn't mean causation. There could be other factors that we're not seeing here that are affecting this, okay? So we can't necessarily say, oh, just because we see this positive correlation, therefore the annual cost, goes up with age kind of thing. There could be some other hidden factors in there that we're missing. So you have to be careful with that. Yes? Yes, you may. After Scott comes back. And then Dylan, you're next. And then Dylan, you're next. You have a math question? Yeah, of course. All right. So anyway, scatter plot, positive correlation, all right? That means then we can say here, so when age increases, annual cost increases. Yeah. Okay? Or again, you can say it the other way too. When age decreases, annual cost decreases. Okay. Question?
One thing about these word problems is sometimes they're just like you can know the answer without even doing the word.
So you were able to tell that from looking at the table? Is that what you're trying to say?
Yeah. No, I mean like just but for the CD one especially, because it's like it says about how many CDs were sold.
You would expect the number of you expected the CD sales to be going down because as the years went on, people are less and less interested in CDs. That's good. Okay?
And all the dots go down.
I'm going to push back on that, though. Right, all the dots go down, right. But I'm going to push back on that and say the importance of data collection is that it can sometimes be against what we would expect, right? And so that's why it's important that we still do this analysis even when we think we know what the answer is going to be, because sometimes we are wrong. And we don't want to just assume what's true and what's not. We want to make sure the data can help us show that's true or not, kind of thing. Okay? We want support with evidence and all that. So that's helpful. Yeah?
So if you decrease your child's age, it becomes less expensive.
Essentially, yes. So you work on that, Tyler, and we can hopefully then save some money in the future,
I have an idea.
Yeah?
Don't have a child.
Yes, around
Use a condom.
That's true. Some people do go that route. They prefer not to have children so that way they can save their money and spend it on other things if they want. It's a choice.
Condom commercial. Don't have a child.
So, let's take a look at the next one here. Go ahead, folks, and plot the data there. Okay? Plot the data. Okay? So you have a lot of points here. Go ahead and plot them. Okay? Plot your data. guess I should go ahead and check to make sure. Oh, it's probably Mr. Thompson banging his head against the wall then. He does that from time to time. Mr. Thompson.
Why does he
Why
act?
do you have to work that against the wall?
Frustration.
Does he act?
He throws his head on the wall.
No, sometimes he bangs his head on the wall because he's frustrated.
Like how?
It's kind of like I feel like doing sometimes.
Mr. Wood, you can't do that. It's bad.
It's okay.
Give like
A little Dane Bramage never hurt anybody.
Does he actually?
Yes. He just told us.
No.
You guys should talk through Morse code with your head.
Actually, that's what our little hole there is for. We can talk back and forth.
You can actually, if you put your head up to one of those like outlets, if there's any, you can hear the conversation through.
Oh, I can hear him when I'm sitting at my desk right there sometimes.
Did you know
That's how I
you
learned
can
math.
charge a metal fork?
Okay, so hopefully we got our scatter plot graphed here. Okay.
That's what education for you.
Now, here it asks us to draw a line of best fit. So, we are to come up with the equation for the line of best fit. Now, there's two ways to go about doing this. Option one, we use our ruler here and we just kind of, again, get the kind of the estimate, a best estimate that we can get here. So let's see here. I see a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. So I'm going to try and get 5 above and 5 below. That's going to be hard to do with the way this is written. I don't know. This is kind of hard to do, isn't it? But there's another way. If you have your graphing calculators, get those out, and I'll show you what I'm talking about. Your calculator's dead? All right.
Well, then get a metal fork. Get a metal fork.
Okay, let's get our calculators out. I got one more calculator. You don't need a calculator? Oh, you need one else? All right, hang on. You don't need one? You got one? I'll go through lots of questions and stuff like that. Okay. So, your calculator can make scatter plots. Your calculator can also give you the equation for the line of best fit. So let me show you how we're going to do that, okay? In order to get the calculator to do this stuff, though, we have to first enter our data into the calculator, okay? So to do that, because scatter plots are part of like statistics, we're going to press the stat button. Okay, so we're going to use some buttons here that you probably have never used before in your life, okay? Dylan, you should sit through this, bud, and not go to the bathroom right now, okay? You need to be here for this. Carson, do you have a calculator?
Yeah.
Okay, you're gonna want to get it out. Alex, do you have your calculator? You got it out? Okay, good. So, press the stat button. Stat button right here, below the delete key. Okay, then hit enter for edit. Okay. Now, you should see some lists here. L1, L2, L3, yes?
Wait, how did you get there?
Stat, edit.
Found it.
Stat, edit is where we are now. Okay? Now, you should have some lists that are empty, right? Does anyone have stuff in their lists? Yeah. If you do, arrow up to L1 and hit clear. Do not hit delete. Arrow up to L1, hit clear, and it should clear out your list 1. And then arrow up to L2, hit clear, and hit enter.
What does delete do?
Delete deletes your list, and then I got to reset your calculator. Okay? Don't hit delete, hit clear, and then enter. Okay, is L1 and L2 gone? Clear, I mean?
I have L1.
Yeah.
L2, did you clear it too?
Yeah, everything's
Okay. So you should have, does anyone not have L1 and L2? Okay, so now we're going to type in our data into L1. Guess what we're going to type in L1?
-2 over 2.
The x coordinates. So this whole row, type them in. So -2, enter. -2, enter. So on and so forth. I'm not going to keep saying them.
Wait, how many times? How many times?
Hit enter after you type your number in, and it'll show up.
How many times?
Type in the entire first row into your L1.
And then for L2, do you do the what?
Yes, you got your two. Matching ones and
You do all of them.
In the first row is the x-axis.
I used the minus sign. You did negative button.
I can't clear it.
What if you put it in the wrong order? Will it go?
You need to put it in the right order.
-2.
So keep the same order and the same pairs of numbers.
Delete it.
Hit the delete button to delete it, or you can type over it.
Delete doesn't work.
Yeah,
It does.
No, you have to go over the number.
And then L2, we just do the Y.
Yeah, highlight the number you want to get rid of and then hit delete. Sorry.
We just do the Y.
Yep, matching Y's and L2.
Alright, so I have like,
I didn't delete it.
I have, no.
Bro, this is
I
so
have 11, negative 2s.
Yeah,
Okay, here
Wait, wait.
I have 11 negative 2s, Mr.
So type in your numbers. So
Mr.
type in
Lamar.
L1, your x value. No, we're doing this one.
Mr. Lamar.
The first one.
Wait, wait, one? Did you change it?
No, I'm at the bottom of my list. If you go to the top, if I go to the top,
Mr. Whitmire.
Mr. Whitmire,
Mr. Whitmire. Mine's not working.
can I use the bathroom?
I need you to be here for this. Sorry, I want you to see this because there's a lot of key presses here. Hold on, I'll let you go. What's up?
Four.
You hit enter after each number.
How do I sort it?
Yep.
Wait, we got 3, right?
No, stat, but I want to make sure.
He says quit Eric.
And then edit. And then, so here.
Wait, why is yours 2, 3, 2?
Okay, so you type in your x row, your row of x's and L1. So like -2, enter, -2, enter, -1, enter, so on and so forth. Okay? And then you go to Y's too.
Okay, what do I do now?
10 more minutes. Less than 10 minutes. 10 till.
I need help on this.
Alright, now what?
Okay? Dylan, what's the question? Why what's the problem?
We go from negative to positive, right?
No, you type in the numbers in the order that they're written here. Whatever that is.
Then how do you sort them?
You don't sort them. We want them to stay paired up. You'll notice. Look here, folks.
Look.
Okay, no.
You'll see here that the -2 and 2 are paired up, right? And the first two numbers, -2 and 2, and then -2 and 3, and you can see -2 and 3, right? So this table that we have here needs to be put exactly into your L1 and L2, okay? Row 1 is L1, row 2 is L2, just like that, okay? Did you use the minus sign for a negative sign?
Oh, that's probably what he did.
Just try that.
Yeah, that works.
And this would be -2 for your first
You
one.
gotta use the negative, not the minus button. For the 3. I messed up. I can't.
Dylan, bring it up here.
I messed up like 5 times.
Yes. Guys, look, I don't know what to tell you because you need to know how to do this on your calculator. So, like, it's you need to be able to do this, okay? I don't know what else to tell you, okay? So, I don't know where you're getting these numbers from either, Dylan. Row 1, type it in your calculator. -2, enter, -2, enter, -1, enter, 0, 1, 1, 1, 2, 2, 3, okay? I'll do the same thing over here, too, for you, Dylan, okay?
I got the.
2, 3, you did. 2, 1, 0, 1, -1, -1, -2, -2. Okay? Learn to type into your calculators, folks. All right? This is something that you have to be able to do on your calculator. You can't do this any other way. Okay? So, I don't know what to tell you. The technology's old. I get it. These were around when I was in middle school. Okay? So we're talking mid-90s, before you were born. These things are older than you are. Okay? So the design, the way it's written, it's old, but you still got to be able to do it. Enough said, okay? Once you've got your data in, is anyone still trying to type their data in?
I have all my data.
All right, well, you have the table up there. Once you've got your data typed in, press the Stat button again. Now that our data is in, we're going to have the calculator do work for us. Go over to Calc, short for Calculate, right? And then we're going to go down to number 4, LinReg. That is short for linear, which means line, and then reg is for regression. You'll notice here, what does this look like? AX plus B. Yeah, it's slope-intercept form. If you hit enter, okay, now different calculators look differently here, okay? My calculator is fancy, so it has this fancy thing. If you have this, this means that it's going to check the X list in your L1 and the Y list is in L2. Didn't we type my X in L1 and my Y in L2? Yes. So I'm going to go all the way down here to calculate and hit enter. Okay, if you don't have that, if you just have something that looks like this, hang on. Okay, stat, calc, linreg, and it looks like, I thought it did that, but I guess I didn't. I did the wrong thing. That's what I did. I did the wrong thing. Hang on. Oh, no, it doesn't do that. Okay, sorry. Yours might look like this. Like this?
Yeah.
Okay. If yours looks like this, if you just hit enter, what the calculator is going to do is automatically check L1 and L2. So if your data is anywhere else besides L1 and L2, you'll get an error. Okay, you won't check that data. So you need to check if it's in L1 and L2. You can just hit enter. Okay, so just hit enter, and then here's the equation for our line of best fit. You can see there's our A value, there's our B value. So there's our slope, negative 0.96, and there's our B value, 0.78. Okay, so that's the equation for our line of best fit. We're going to have to round, obviously. That's okay if you don't have R. Yeah, all right, Dylan. I'm not up to help. I'm sorry. We'll have to worry about that another time. I can't right now. We're not going to run out of time. So. Okay. Again, folks, it's all fun and games now that you're lost and you weren't paying attention, so you don't know what you're doing. It's silly. I get it. Come to test or quiz. It's not going to be so funny. Maybe it will be. I don't know.
Are we allowed to ask you how to put it?
You'll need to know how to do it without me prompting you on a test or a quiz. But we'll get more practice with it.
I got something that just is like a line wrong.
Okay, I'll come and take a look at it in a second here. Okay, I'm not quite done saying what I want to say. So, if you want, we can then see this graph on our calculator. Okay, so if you want me to show you that real quick here, I can show you that too. If you go to y equals, all right, so press the y equals button. All right, we'll see it, Ella. We're not going to have homework, okay? No homework or anything, so. All right. Type in that abbreviated, the estimated, the rounded line of best fit equation that we came up with there. Then we also have to go up to our stat plot here. So if you press second y equals, and we're going to go to plot 1 here. Okay. So second y equals, turn on, and we're going to go to plot 1. Turn it on. Okay, we're going to turn on the data plotting, and then you'll know, what's that? Just hit enter on the on, yeah, and it'll switch over to on. And then the type is we want this. This is the scatter plot. Our data is in L1 and L2, and then there are the marks. Okay, so if I hit graph, there's the data with the line of best fit. Okay, if I press zoom and then stat, zoom 9, it fits it better, a little bit better there to see our line of best fit compared with our data. Okay. So, I'd like you to try, actually, well, I just told Ella that, but oh well. I'd like you to try number 4 here. She'll be fine. Okay? So number 4, for your homework tonight, to try it out, at least draw the scatter plot and then try and come up with that line of best fit using your calculator. Okay? Kendall, I don't know if you're going to have to get new batteries or something like that because I can't let you take that home, but there you go. Okay, so try number 4 there. Okay? For tonight.
No, I just didn't.
Where's the chart? I'm gonna come around and get your calculator or your rulers.
I got my class. I'll touch that.
Oh, yeah, go ahead. And Carson, here's the box for you if you want to put them in the box too while you're doing it. Thank you, Carson.
You forget out here.